Hey everyone, welcome back to the channel. Today's video is all about combining the exciting world of generative AI with Python to build something really cool. We're going to be diving into how you can leverage generative AI to create a Python application that includes a comments section. But with a twist, the comments will be automatically validated against a set of policies. This is a fantastic way to streamline your app's functionality and ensure a safe and positive user experience. So, if you're interested in using generative AI to take your Python development skills to the next level, then stick around because this video is for you. For the app itself, we'll be using our usual tools: FastAPI, Pydantic, and Postgres. These are great choices for building robust and scalable applications. And to handle the policy validation, we'll be leveraging the power of OpenAI's models. All right, before we jump into the code, there's a quick setup step. If you're new to OpenAI, head over to their website and register for an account. Once you're in, click on the Login button and then navigate to the API section. This is where things get important. We'll need an OpenAI secret key to access their powerful API. Think of this key as a password. It grants your application access. If you don't have one already, click on the Create button to create a new key. Make sure to keep it safe, as we'll need it to connect our Python application a bit later in the video. Also, make sure that there are a couple of dollars on the OpenAI account to actually be able to use the API. Don't worry, for this tutorial you need at most a couple of pennies. All right, folks, time to dive into the code. Let's crack open PyCharm and get started. As always, you can find the complete code for this tutorial on GitHub. The link is waiting for you in the video description. To kick things off, I'll give you a quick rundown of our app's data model and the corresponding CRUD operations. Now, if these concepts are new to you, no worries. I've got a whole video dedicated to explaining them in detail, and you guessed it, the link's in the description below. All right, let's take a closer look at the data model for our application. Here, you'll see that we only have one table involved, the comments table. It stores three things: a unique identifier for each comment, the content of the comment itself, and a timestamp to track when it was created. To interact with this data in our Python code, we'll define two Pydantic models. These models act like blueprints, ensuring our data is structured correctly. The first one, called comment, is for reading existing comments. The second one, comment input, is specifically for creating new comments. One interesting thing to note is that the comment input model automatically generates the ID and the creation timestamp. Why? Because we don't want users to provide those values. The system handles them automatically. This keeps things clean and organized in our application. All right, with the data models squared away, let's move on to how we interact with that data in the database. Here, we'll use SQL templates to define the core operations for our comments table. We'll only need two templates: one to create a new comment, another to retrieve a specific comment by its ID. The last piece of the puzzle is the CRUD class. This class acts as a bridge between our Python code and the database. It utilizes the SQL templates we just defined and injects actual data to execute the desired operations. All right, folks, buckle up because we're about to get to the exciting part: integrating OpenAI for comment validation. First things first, let's talk about how our application initializes on startup. We do this through a function cleverly named lifespan. Here, we'll establish the overall state of the app. Inside this function, you'll see some magic happening. First, we create an instance of a class called environment. This little guy is responsible for pulling in all the environment variables we define in our operating system. This is my recommended way for securely storing sensitive information like your OpenAI API key. The environment class is a simply pedantic model that I defined in a separate file here. Once we have access to those environment variables, we can create two important things: an active connection pool to our Postgres database and an OpenAI client. The latter acts as our bridge to interact with OpenAI's powerful models. All right, now that we have everything set up, Let's dive into the heart of the video, using OpenAI to create a powerful comment validation system. To achieve this, we'll define some key functions within our policy checker, all powered by the magic of OpenAI. The first step is to actually define the policy itself. And here's a fun fact. I used generative AI to create the policy for this Python blog's code of conduct. Talk about irony, right? Now, with our policy defined, we need a way to enforce it. This is where the real power of OpenAI comes in. We'll create a function called acts as our comment validation gatekeeper. This function takes two arguments: the OpenAI client we created earlier and the actual input comment. And it returns a simple true or false value green light if the comment is okay, red light if it violates the policy. Inside this function, you'll see some interesting things happening. First, we define a few messages that will be used by OpenAI to understand the context of the comment analysis. The first message defines our actual policy, and it includes a special element called the system role. This role essentially tells OpenAI to treat this message as a predefined rule or guideline. Next, we craft another system message, specifically asking if the user's comment adheres to the policy. We also emphasize to OpenAI that the expected response should be a simple yes or no answer. This helps ensure clear and concise communication. Finally, the last message is the actual user comment itself. Here we also designate the user role to signal to OpenAI that this is the content being evaluated. With these messages in place, OpenAI has all the information it needs to analyze the comment. Now, with those messages defined, we can leverage the power of OpenAI's chat completion functionality. Remember our OpenAI client? It provides a feature called chat completion that allows us to analyze text based on a conversation history. We feed the OpenAI client our three crafted messages. OpenAI then analyzes this conversation and generates a response. We check the first part of OpenAI's response. If it starts with yes, then everything is good. The comment is considered valid according to the policy, and we return true. If not, we return false, indicating that the comment violates the policy. We've covered the core functionality of comment validation, but let's take it a step further and enhance the user experience. In this part, we'll create another function that provides a reason why a comment might violate the policy. This new function, just like its counterpart, takes two arguments: the OpenAI client and the comment itself. However, this time, instead of a simple true or false value, it returns a string containing a reason for potential policy violation. This additional functionality is valuable because it provides users with clear feedback. If their comment gets flagged, they'll understand why and potentially have a chance to revise it to meet our community standards. This function, similar to the validation function, relies on crafting specific messages for OpenAI to understand the context. The first message is again the policy itself. The second message is specifically asking OpenAI to explain why the user's comment violates the policy. And the third is again the user comment itself. We let OpenAI again analyze this conversation and return the response content. All right, folks. Now that we have our powerful policy checker in place, let's see how to seamlessly integrate it into our FastAPI application. This is where FastAPI's dependency injection feature shines. Think of dependencies as pre-built components you can inject into other functions within your code. They can be simple functions or even chained together to create more complex logic. We need the usual dependencies for creating our scrud instance, and we need another dependency to retrieve our OpenAI client. And the last dependency utilizes our policy checker. Here's how it works. First, we use our function that approves the comment. If the comment is approved, everything is good to go. However, if the comment gets flagged, we don't want things to crash. Instead, we'll leverage FastAPI's exception handling capabilities. We'll raise an HTTP exception that includes the reason for rejection, as generated by OpenAI. This provides clear feedback to the user and allows them to potentially revise their comment. All right, everyone, let's put the finishing touches on this project by creating a route for users to submit comments. We'll define a post request endpoint for creating a comment. This endpoint will have one key dependency, our trusty policy checker. Here's the magic. The policy checker dependency is executed before the actual comment creation function. If the policy checker raises an HTTP exception, meaning the comment violates the policy, the comment creation never happens. The user will receive a clear error message with the reason for rejection. However, if the comment gets the green light from OpenAI, the actual creation function kicks in. It creates the comment within our post-egress database and returns it to the user for confirmation. This approach ensures a smooth and secure comment creation process. Users can submit their thoughts, and our system automatically validates them against our predefined policy. All right, folks, it's time to put our creation to the test. Let's fire up this Python application and see how it works in practice. Before launching, make sure you have all your environment variables set up properly. To configure your environment variables, head over to the Configurations options within PyCharm and then select Environment Variables. There you can add all the necessary settings. Once everything is in place, all you have to do is click the glorious Run button. All right, everyone, buckle up for some real-world testing. I've cooked up a couple of HTTP requests to see our comment validation system in action. Let's see how it handles some positive feedback. First up, we have a comment praising the coding style. Let's see what happens. Excellent! The comment sails right through, no issues detected. Now let's test something a bit different. How about a simple, I love you? This one triggers a violation because it is off-topic and does not relate to coding. Look at this fantastic explanation our API provides. Next, we'll explore how it handles critiques. First up, a comment expressing some dissatisfaction. I don't like the code because it feels too instructed. As expected, the comment passes through without a hitch. Our system understands that constructive criticism is a healthy part of the development process. Now, let's crank things up a notch with a more pointed critique. This code is worse than what my 3-year-old daughter could write. Uh-oh, looks like we hit a snag. Our policy checker flagged this comment for violating our policy on personal attacks. This is a great example of how our validation system finds a balance between allowing valuable feedback and preventing negativity. All right, everyone, that's a wrap for this episode. We've covered a lot of ground building a data model, crafting CRUD operations, and the star of the show, using OpenAI to create a secure and informative comment validation system. I hope you learned how to harness the magical powers of generative AI to supercharge your next application. Remember, AI can be a powerful tool to automate tasks, improve efficiency, and even create clear and comprehensive policies. If you enjoyed this episode, don't forget to smash that like button and subscribe for more exciting content. See you on the next one.